Okay, so the coefficient of static friction between rubber and the pavement is 0.8. On how steep a hill can you leave a car parked? So the 0.8 is 9.8 times 0.8, which is the effect of gravity. And so it's saying when you're parked on a level ground, the coefficient of static friction is 0.8 in this direction, right? And the effect of gravity is this way. And it doesn't really have an effect when you're at a horizontal because the angle here is 0, right? And friction acts along the x-axis, right? So the effect of friction will be the cosine of the angle, which is in this case 0, and so it's 1. And gravity acts perpendicular to the ground. So that angle is sine, and sine of 0 is 0. So when you're at a 0-degree angle like this on flat ground, the cosine will be 1, the sine will be 0, and so you'll have the full effect of the 0.8. But as you increase the angle of the hill, as this angle increases, this sine is going to get bigger and this cosine is going to get smaller. And there's a point at which the sine and the cosine, the impact of those two, will equal each other. And that's the point where the car will start to slip. So this way is the effect of gravity, and this way is the effect of friction. We can write that as UK, right? Coefficient of friction. Actually write it as US because it's static friction. And so there's some point where this force will equal that force, and that's what we're trying to find. So there's a point where the sine of this angle here, sine of theta, times gravity equals the cosine of theta times the coefficient of friction. Alright, so in this problem, the coefficient of friction is 0.8, and that's a measure of gravity. It's 0.8 of gravity. So we can just write gravity as 1 and cosine as 0.8. Sorry, static friction is 0.8. So then when you rearrange this to get like terms together, you have sine over here divided by cosine equals 0.8 divided by 1. Okay, well the sine over cosine simplifies to just tangent. That's what it is, right? And its tangent of theta equals 0.8 over 1 is just 0.8. So now all you have to do is find the arctan of 0.8, and what you get is 38.66 degrees. And that is the maximum angle that this car can be parked without slipping. So that is your answer.